Alright, so in this video, let's go over integrals of exponential functions. In particular, we're going to go over exponential functions that just look like this. That's really all we're going to consider for the rest of the semester when it comes to integrating exponential functions. So, remember, when you take the derivative of this exponential function, you get k e to the kx, or xk, doesn't matter. But remember, but essentially the k is what comes down, okay? And remember that the difference between this and the power rule is that now the variable is in the exponent and the base is just a number. So again, what happens is you get itself times k, which is of course the rate of the exponential function. Now let's say we want to go backwards. We want to integrate this function. So if we integrate e to the kx, what we're going to get is 1 over k times e to the kx. In other words, it's itself times 1 over k. And then, of course, the constant of integration. All right? So let's apply this formula over and over again, just 3 or 4 times. So I'll keep this formula up here in the right, but it's pretty simple. If you want to integrate e to the 3t, what are you going to get? You're going to get 1/3 times e to the 3t. In other words, itself times 1 over the rate, plus the constant of integration. Let's do this for e to the minus 3t. All right, not a problem. We're going to get itself times 1 over negative 3 plus c. So, of course, it doesn't matter where that minus sign goes. You could write it out in front like that. All right? Okay, and the third one, we have integral of 5 e to the minus 5z. What can you do with the constant? Just let the integral pass right through it. So we're going to get 5, right? But then we integrate this part, so we're going to get itself, e to the minus 5z, times 1 over negative 5. So when you simplify that, of course, plus the constant of integration. When you simplify that, 5 cancels, you get negative e to the minus 5z plus c. All right? Not bad. So now let's tie in some of the previous videos with this function. Here we go. We take the integral of this entire expression, 1/2 square root t minus e to the minus t minus 1 over t squared. All right, so let's just watch out for these minus signs and apply the power rule a couple of times as well. So let's set it up. We have integral of 1/2 t to the power 1/2, setting us up for the power rule. Minus e to the minus t, I won't touch that part, but you can notice that the k is a negative 1. And then we have minus t to the minus 2 dt. So we have two power rules here, and then we have an exponential rule right here. All right, so let's go ahead and do that. 1/2, we'll just write it down, copy and paste it, right? Now let's integrate t to the 1/2, so we'll get 1 over the power plus 1. Well, hopefully you're good at that by now. Let's just put 3/2 times t to the power 3/2 minus, so we have an exponential function and the k is negative 1, so we'll have minus 1 over the k, e to the minus t, just itself. And then finally minus 1 over the power plus 1, t to the power plus 1, and then the constant of integration. So we'll simplify all this. 1 over 3/2 is just 2/3. 2/3 times 1/2 is just 1/3. T to the power 3/2. All right? And then we'll get plus e to the minus t, because 1 over negative 1 is negative 1, and minus negative 1 is equal to positive 1. And we have 1 over negative 2 plus 1, that's 1 over negative 1. Again, that's going to become plus t to the minus 1 plus c. And so if you want to simplify it, you get 1/3 t to the 3/2 plus e to the minus t plus 1 over t plus c. And there's your answer. All right? So that's pretty much it. It's pretty simple, just another formula. All you have to remember is that when you have an exponential function, the derivative, you know the k comes down, but if you integrate it, what comes down is 1 over k, if you want to put it that way. And of course, if k is equal to 1 and you just have e to the x, then you get the usual formula that the integral of e to the x is itself, precisely because the derivative of e to the x is itself. All right? And if you want to, just go ahead and check that this formula works. If you take the derivative of 1 over k e to the kx, the k would come down and cancel out the 1 over k that was in front. And so you would just get e to the kx back. All right? So that's definitely what the formula has to be. And of course, when you integrate the constant of integration, it becomes 0. So this is definitely the right formula for the integral.